Okay, in this video, we're going to look at building a fun little project, a little novelty project. I call it my smart candle. And it involves one of those little flickering candles you could buy at the dollar store. You can see here, has a little LED inside, and it flickers so it looks like a burning candle. So if you have one of these set up in your house, and you come up to it and blow on it, the candle will go out. So you can get a little reaction from anybody watching you do that. Now in about 10 seconds it will time out and the candle will relight, so you could do the sequence all over again. So she's back on, so I'll do it again. But this time if you bring a match or a lighter up to it, she'll relight. So I'll do it again, I'll blow it out and I'll relight it. So it's a little novelty project you could build. In this video we'll go over how you could build one of these little smart candles. Okay, here's the control circuit for my smart candle, and I've built it on my breadboard. Now there's two main components to this circuit. There's the sound detection module, that's this module here. So it has a microphone, amplifier, and a comparator, and it has three pins, ground plus 5 volts and out. And you can pick that up online, it's pretty cheap. And the second component is a CD4093, that's a Schematic Diagram NAND gate, that's a chip here. That controls all the timing and all the logical functions. Now this LED here that's on, that simulates my candle, so my candle is lit, and it's being fed by 3.3 volts from this 3.3 volt regulator. So it gets its 5 volts from the rail and produces 3.3 volts to turn on the LED or the candle. Now this transistor here actually switches the candle on and off. Now when I blow on the candle, the sound module picks it up and extinguishes the candle for about 10 seconds, and then the candle comes back on. So if I swipe my finger across the microphone, you see the candle goes out, and after about 10 seconds the candle will come back. Now if you want to relight the candle, that's sensed by this sensor here, light dependent resistor. So if you put a match or a lighter near this sensor, it will drain this capacitor, which will shut down the timer and turn on the LED. So that's the basically circuit there, but one thing we have to do, we have to calibrate the circuit to the ambient light. So if I turn off my bench light, I have a pot here, so I could adjust it to the ambient light. So you see the top LED come on, and I just turn it until it turns off. Now if I turn on my bench light, you can see the top LED comes on. If I turn it off, it goes off. So it has to tell the difference between the ambient light, and if you introduce a flame, that will turn on the LED right there. So after it's calibrated, then you're all set to go. And all you have to do is blow on the candle, they'll turn it off, and if you bring a light close up to the sensor, it puts the candle back on. Okay, here's my modified candle. So I've taken one of these $2 candles and modified it for my circuit. You can see on the bottom, I've taken out the coin battery, removed this screw and taken out the battery and soldered 2 wires onto the terminals. So this is where you feed your 3.3 volts into the circuitry of the candle here to turn on the candle. Now on the back side, I've mounted a light dependent resistor. That's it here. So when you have it set up, it's hidden. It's in the back. So when you blow on the candle, your microphone is also behind here. You'll turn off the candle. And when you bring a match or a lighter up to this point here, this sensor will pick it up and then turn back the candle on. Okay, here's the schematic diagram of my smart candle circuitry, which I built on my breadboard. And you can see the 4 Schematic Diagram NAND gates, and you can see the microphone module on the very left. Now when we first power up the circuit, this 33 microfarad capacitor will be discharged. So we'll have a logical 0 on the input of this NAND gate, and a logical 1 on the output. That'll turn on this MOSFET transistor, which will feed a ground to one side of the candle. Now the other side of the candle is getting 3.3 volts from this regulator, from the output of this regulator, which is being fed by the rail, 5 volt rail. So when we first power up the circuit, the candle will be on. Now when we blow on the microphone to extinguish the candle, the collector on the comparator inside the microphone module will go low. So we'll have a low on the input of this NAND gate, and we'll have a high on the output, which will charge up this capacitor. Now we'll have a 1 on the input of this NAND gate and a 0 on the output of this NAND gate. That'll turn off the MOSFET to turn off the candle. Now the candle will be off until this capacitor here discharges down to 0. We'll get a 0 back on the input of this NAND gate and a 1, which will turn on the candle again. Now if we blow out the candle and we want to turn it on right away with a match, then we apply a match to this LDR, this light dependent resistor. The resistance will drop, we'll trigger this NAND gate, and we'll have a low on the output of this NAND gate. Now we'll drain off this capacitor through this 100 k ohm resistor. Now I put a 100 k ohm resistor in there so we don't drain it right away, so it simulates the actual lighting of a candle. Because when you light a candle, it takes a while for the wick to take. So as we apply the match to the LDR, we'll drain the capacitor and the candle will come back on. And this pot here adjusts our ambient light calibration. So we adjust the pot until this LED comes on, then we adjust it until it just turns off. Now the whole circuitry is ready and it's calibrated to the ambient light and it's ready to be triggered. Okay, now you know the secret behind the smart candle and how it operates. And you could be creative and build your own little enclosure, like a box or something. You could put the whole circuitry in there and mount the candle on top. And it's really fun when you have a bunch of people over, especially little kids, and the reaction that you get when you blow out the candle and relight it. Now I built this project using the Arduino Nano, but I thought I would use discrete logic circuits so you could get some experience on breadboarding and circuit design.